4.4 Permutations with repeating objects. Explore. Consider the words bike and book. How does the number of ways that the 4 letters in each word can be arranged differ? Why? So with bike, it's 4 times 3 times 2 times 1, which is 4 factorial ways. But with book, since there's these 2 repeating O's, it's going to be less than the number of ways for bike. So let's figure out our formula. So here we have a plate problem where there's 3 identical plates and 4 different colored plates. If they were all different, then there would be 7 factorial ways. But since there's some that are repeating, we need to divide by the number that are repeating factorial. So how many are the same? 3. We've got 3 identical plates, so we're going to divide by 3 factorial. So all you do for these ones is you take the total number, divide it by the number repeating with their factorials. So 7 factorial could be rewritten as 7 times 6 times 5 or 3 factorial over 3 factorial. And then our 3 factorials cancel, so 7 times 6 times 5 times 4 is more than that. This is example 1. In regions of India, China, and Nepal, it's common to see prayer flags. Each flag has a prayer written on it, and the color is used to symbolize different elements. So let's say that you have, you want 9 flags, 1 green, 1 yellow, 2 white, 3 blue, and 2 red. How many different options are there? So these would all be things that are repeating. How many total flags do we want? So it means 9 factorial is going to be on the top. Then the different things that are repeating is there's 1 green flag. Do we need to write 1 factorial? Because 1 factorial is 1. 1 yellow? No, we don't need to write that either. So 2 factorial for the 2 white, 3 factorial for the 3 blue, and 2 factorial for the 2 red. So this then you can do in your calculator, 9 factorial divided by 2 factorial, 3 factorial, 2 factorial, and see what you come up with. 15,120 should be your answer. Example 2, how many ways can the letters of the word Canada be arranged if the first letter must be N and the last letter must be C? So it starts with an N, it's ending with a C. So how many different ways are there for your first position? How about your last position? And then in between, there would be 1, 2, 3, 4 other possible. 4 factorial, but there's not 2 A's, there's 3 A's. So divide by 3 factorial to get our answer. So 4 factorial divided by 3 factorial. So example 4, in how many ways can all the letters of the words, I'm not going to try to pronounce that, be arranged? If there are no restrictions. So if it does not matter, things repeat or not. Pardon? 11 factorial. Okay. Sorry, I shouldn't have said if things repeat or not, because there are things that repeat, so we need to consider those. So it's 11 factorial over how many O's are there? And how many E's are there? And K's? And S's. So 11 factorial divided by 2 factorial, 5 factorial, 2 factorial, and 2 factorial. So your answer should be 41,580. Now let's look at B. If the arrangement must start with E, 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 that means the first spot, there's 3 E's that you could choose from. So for part B, we have 5 E's, and we need to pick 3 of them, and we're going to multiply that by the 8 letters that are left, but then divide by the different repeating options to get 151,200. Okay, part C. If the arrangement must start with an R, how many ways are there if it must start with an R? Good, 0 ways because there is no R. And part D, if the arrangement must start with a K and end in a K. So that means it starts with a K. How many options are there for that? 1 on each end, because it actually doesn't matter which K goes where. And then in the middle, there are 9 factorial ways, or 9 left, divided by what?
4 factorial, 5 factorial, 2 factorial.
Good. And no other 2 because we've already used our k's. So the k's are gone. So multiply all these together, and you should end up with 756 possible ways if it's repeating. Then you have an assignment, page 266, to work on now.